Institute on Ecosystems, and tonight we have with us Paul West. Paul is from the University of Minnesota. He is co-director and lead scientist of the Global Landscape Initiative at the University of Minnesota's Institute on the Environment, similar to us. His research develops solutions for increasing global food security while decreasing negative effects of agriculture on water, climate, and biodiversity. He leads the team's efforts to get its science out of ivory tower and into the hands of people affecting change. So very much a policy and large scope of inference in his work. Before joining U of M, Paul worked 17 years in the Nature Conservancy and gained an interesting perspective, I think, there. He received a pair of Bachelor of Science degrees, one in soil science and natural resources, and one in restoration ecology, which is actually part of a landscape architecture program at the University of Wisconsin in Madison. Also a master's degree in restoration ecology, a PhD in limnology and marine science from the University of Wisconsin, which interestingly leads him to agriculture. I first heard Paul give a talk at an international meeting in Spain and was incredibly impressed with the scope of his work and thought it was interesting that in Montana we don't often think or take advantage of people that are thinking at real global scale. So I was excited about the possibility of having Paul come and talk to us, and hope his talk will be equally interesting to you. So without further ado, Paul West.
How does this work? Good. And thanks, Bruce. And thanks for having me here. I'm really excited. I've had a great few days enjoying your excellent state and this area outside the city. It's completely beautiful. We do not have any mountains. We do not have large open spaces. So it certainly is it's awesome to be here. So as Bruce said, I'm going to talk for a little bit about the really large issues that are focused or that are centered around figuring out how we can feed all the people now as well as in the future. So there's a couple parts to our challenge here. Is that first we have to figure out how to meet the needs of everyone who is currently on the planet, and showing up to dinner is another huge number of people. And actually, when you look at what the needs are estimated for the amount of food that needs to be grown in the future, part of it is driven by more people on the planet, but actually a bigger part is driven by more people around the world are eating more meat. So that means that a lot more of the crops are needed for feed, and in many cases that isn't all that efficient, and I'll talk more about that in a bit. So another part of the challenge is that the way we currently grow our food uses a tremendous amount of water, of fertilizer, has impacts on our climate. So it's a double challenge of figuring out how to grow more and do it in a way that is better for the planet and for us in the long run. And of course, if that wasn't a challenge enough, we have to figure out how to do this in a planet that is warming, on a planet that's warming. And when we think about agriculture, most of us, think about individual farmers because that ultimately is where our food is grown. So it might be like a farmer in the U.S. It might be another place in the world, but ultimately this, of course, is where our food is produced. But the way I and others on our team and similar groups around the world tries to think about it much more at a larger scale and acknowledging that there's not a farmer here and there's a farmer there. There are a billion farmers on the planet. And the billion farmers on the planet have this working? It's supposed to be a movie. Oh yeah, it goes. All right, it's faster than I thought, but you can see a little movie here. So over time, for growing food, we're now using about 40% of the ice-free land on Earth. And most of the land that we're using is the best in terms of agriculture. So we don't necessarily have a lot of options for finding somewhere else in the world where there's another Iowa or Montana. So a real challenge is to figure out how to grow more or use what we have more efficiently on the amount of land that we currently have. Another thing that is important is that while ultimately the food is produced on individual farms, the food that's produced is traded all around the world. So about a fifth of all of the calories that are produced on croplands as well as livestock is traded. Important thing to know too here is that there's a few crops, wheat, soy, and maize, that account for about half of all the calories that are traded. The reason I mention that here is that you'll see over and over in this talk that there are a few crops and commodities and a few places in the world that explain most of the global story in terms of food production, food availability, impact on climate, etc. So what I'll talk about for the next few minutes is kind of a three-part story. And the first part is, as part of the solution, is to identify opportunities to grow more on our current land that we're currently in agriculture. One of the challenges that we face is that we have done some analysis looking at wheat, rice, maize, and soy. And I know it's only a small number of crops, but it's almost all the calories that are produced on croplands, for crops. So what we did was we gathered information from agricultural trends of wheat, rice, maize, and soy from 1960 up to the present. And what we found with wheat and rice is that about 40% of the area that is growing wheat or rice, that our yields over time have flattened out. So in order to meet a future demand that's expected to have needing to double the amount of crops that are produced between 2010 and 2050, what we're seeing from our major crops is that we are not on track. Maize or corn and soybean are better off. However, where they are well off is usually in places like the US, where the majority of the corn and soy that we use is for feed and fuel. So as part of the story, what we did was we looked at I guess a number of other studies, or the overall narrative, at least in the US, is how do we increase yields where our yields are already really good. That is very important to do, but we kind of asked a different question. Instead of saying, how can we raise the ceiling, is we asked, well, what if we brought the floor up to at least half of what is possible? So in this figure here, what you see is those areas that are in dark green are those places where the yields are at least half of what is possible in those places. So everything that's light green and yellow and orange are places where the yields are lower than half. So we just asked, well, what would that mean if we increase the low yielding areas up to at least half of what's possible in those areas? Sorry, I'm doing that. So we kind of mapped that out in terms of calories, and we did this for 17 crops, which combined make up like 82% of all the calories, I think, that are produced on croplands. So there's a tremendous amount of calories that can be grown by even just bringing up the floor to half of what is possible. When you zoom in on smaller areas, this was a part of the project that we've done with National Geographic, where we had highlighted that what you see up here are those areas that are in green are closer to a ceiling of what is possible in those places, and the areas that are in tan and brown are the areas where all the yields are a lot lower than what's possible. So the second part of the story I'm going to talk about is how do we use what we grow, how do we use that more efficiently? Because we already produce enough calories around the world to feed everybody. One of the big ways we can increase our food security around the world is driven by what we eat. And more what we see on our plates is less and less like what you see here, and more like what we see here. And the reason this has an impact is that in many places in the U.S. and other places in the world where a lot of feed is used in order to produce cattle or chicken or hogs, that there's not a one-to-one efficiency in terms of the amount of calories in feed versus the calories that end up in the meat. So with beef, it takes about 33 calories of feed in order to make a calorie of beef. So when you kind of map that out, which we've done, is you look at the inefficiencies in the system, and those areas that are in red are where the majority of the calories don't end up on the plate. And that is even accounting for the calories in the meat and dairy and eggs and other animal products. Whereas the opposite, those areas that are in green, are places where what is grown is eaten by people. This is pretty stark. I mean, like where I live in the Midwest, you know, we like to say that we are feeding the world. And our farmers do an amazing job, and it's a really hard job. And the yields are very high. But when you look at how they're used, we are largely feeding our cars and cows in the US and pigs in China. And when you look at it across the globe, I think the number is like, is 36% of all of the calories that are produced on our croplands don't end up on the plate. And it's because of these of uses for feed and fuel. So by no means do I or others on our team or advocate for everybody being a vegan or a vegetarian. What our intent here is to really show like what is possible, and to really highlight that even small changes in diet can have a major impact on how much food is available for people around the world. Another big issue is food waste. So about a third or 40% of the food that's produced on the croplands is lost. People who get into the nuances of this separate out loss and waste. So what they mean by that is that in a lot of the developing world, you have loss. So about a third or more of the crops that are produced either stay on the field or rot in storage or spoil on the way to a market. Here and in Europe and many other places in the world, you still have the same amount of calories that are missing, but it's more in terms of waste. So it's stuff that we don't eat, and it stays in our fridge, or it's waste at the grocery stores because it's ugly, and other factors. And it's particularly important because when you look at in combination with that our yields are not on track to meet a projected demand, we have to find other alternatives. And even based on what we know is possible from yields, at least according to our current varieties and current management practices, the amount of opportunity that's there for more calories is much smaller than the opportunity for more calories if we have less waste and change our diet, even in small amounts. One thing we did is we looked at, interestingly enough, earlier today I said to someone that this talk would not have a slide with a whole bunch of numbers and say, now you don't have to read all this, but it turns out I am going to say something like that. So I guess I should cover part of it up. But what our main point that we tried to do here was that most of the studies on food waste kind of treat all food waste the same. But if you look at all the calories that are embodied or embedded in the meat that we eat, even wasting like a small part of a burger or a steak or ham or whatever has a much bigger impact than salad or vegetables. It's not at all to say that all waste isn't a problem, but if we are going to cut back on waste, which we should, having a focus on a few pieces of, or a few types of food have much more of an impact than others. And got a little stat up there for that. So the third part of the story, so we've talked about how to grow more food on existing land, how to use what we already grow more efficiently, and then this third part here is how do we grow food more efficiently? So when you think about croplands, what explains most of the patterns around the world in terms of yield, it's largely explained by climate, water, and fertilizer. There are certainly a lot of other factors on how a farmer is managing the land. Is it tilled? Is it no-till? How is it fertilized? But broadly speaking, you can explain most of the patterns of yield around the world from water, fertilizer, and climate. So agriculture uses 70%, or how we use water for agriculture accounts for 70% of all the water use on the planet. If you do the math in a way that you look at water that's applied and doesn't end up back in a stream, so it's water that's used and then evaporates, so it's not lost, it goes somewhere else. When you do the math that way, 90% of water that is used by all people on the planet is for agriculture. And it turns out only a small number of crops. So what we did here was we looked at all water limited areas across a number of crops. And like I mentioned before, what we find over and over again is that most of the stresses or opportunities in the food system as a whole, or at the global scale, is largely driven by a small set of countries and a small set of crops. Now in the past, and maybe still, a lot of people will say, well, water is important here, but if they have a drought somewhere else in the world, it's not my problem. And of course there are like ethical reasons on why that is wrong, but we're seeing that our food stores are really at the margin now. So if there is a drought in another place in the world, like in Russia, and the yields on wheat are decreased, and they then have a ban on exports of wheat. It affects our prices for wheat here, access for wheat all around the world. When people are hungry and thirsty, they get upset, they have war. So food is a really big part of not only how we feed ourselves, but really the overall stability of our life on Earth. And I mentioned just a minute ago that a small set of crops is what is using most of the water. So what we really try and point out is that if we want to influence how water is used in agriculture, not that other places aren't important, but you need to focus on these, this small set of countries and this small set of crops, because the other crops, other places, will matter a lot for that area, but globally it's not going to move the needle, so to speak. So I talked about the amount of water. Now, if you look at water quality, kind of an interesting story. So about, this is the excess nitrogen, I believe, that's on farm fields. So whether or not you're looking at phosphorus or you're looking at nitrogen, about half of the nutrients that are applied end up in the crop at the time of harvest. With phosphorus, as long as you don't have erosion, it can build up in the soil. Nitrogen, as I'm sure many know, tends to convert to a form very quickly, and it leaches out of the system and ends up in our groundwater, our streams, on the coasts. Similar to what I talked about with water, again, a small set of countries, a small set of crops, kind of explain most of the story. When we look at climate change, agriculture is somewhat of a sleeping giant in that the greenhouse gas emissions from agriculture are, and even forest loss for expanding agriculture alone, the emissions are more than all the planes, trains, and automobiles on the planet. And it's like those and another set. So it's twice as much. So in order to address these issues on food security and the environment, agriculture really needs to be a part of the solution. There was a study last year, or maybe it was this year, that did kind of a hypothetical exercise and to say, okay, a number of countries have made a set of commitments in Paris, and there are another set of commitments through other agreements, and to see, like, okay, well, if all those were put in place, like, would we meet a target of 2 degrees Celsius or not? And as part of their exercise, they really looked at, in order to really change things by the end of the century, the amount of reduction in emissions is massive. And so when you look at what agriculture could contribute, and in this exercise, as far as estimating what is needed, as you can see here, they had estimated that at least one of the pathways is to get emissions from agriculture down to 0. I mentioned earlier that a few minutes ago that agriculture accounts for a quarter or so of all the emissions. In the past, that was largely from clearing a forest in the tropics to expand agriculture. And that's certainly still a driver of the emissions, but now management is more on par with that. So this slide shows it here, The green line is management of crops and livestock, and the emissions from forest loss is decreasing. So when you look at agricultural management, the biggest source of emissions is methane off of livestock. When you map out emissions from our croplands, you see that, at least the numbers up on the top, is that about half of the emissions from all the croplands are from rice. And 30% or so is clearing of peatlands, mainly in the tropics, but also in the northern US and Europe and Canada. And then another bit is from fertilizer use. The methane from rice happens because as rice is produced and flooded, it creates a condition where you have a release of methane. And methane's impact on the climate, it's shorter lived than CO2, at least in terms of how long it impacts things in the atmosphere, but it is about 40 times as strong as CO2. So it's short-lived, but in that time it has a big punch. The other source is burning of peatlands, and while that's over a much smaller area, and the overall effect on the planet is not as high as rice, but where it occurs, it has a tremendous amount of impact. And much of that is in Southeast Asia in order to produce oil palm. Another big source is fertilizer. So about 1%, although it's not exactly that, but about 1% of all of the nitrogen that's applied is converted to and released as N2O, laughing gas. So when you map this out, similar to I kept saying over and over, a small set of countries are where the hot spots are, and a small set of crops. We kind of rolled all this stuff together in a paper, a lot of what I've been talking about, and just really tried to hit home that, again, small set of countries and commodities really drive most of the story. When we start to look forward into the future, we think about climate change. And it's not as simple as this, but one way to look at it is to kind of look at the relative change in temperature and wetness or dryness. So you can start to look at where is there an analog, or where are places that have a similar climate now that our climate might have in the future. Our meaning if we're here in Montana or Minnesota or whatever. What a lot of the studies have done, and these aren't ones that our team has done, but what a lot of the studies have shown is that the models kind of estimate that, looking out into the future, that the impact on crop yields in the high and mid-latitudes, it's more, in some cases it's increasing, in some cases it's decreasing. There's a whole lot of uncertainty in the mid-latitudes. But in general, across all the models and various studies that people have done, really show that the yields in the tropics are likely to be hit hardest. And unfortunately, that's where yields around the world are already very low. Okay, let's skip that. So what I talk about here in a few slides is there's been a lot of work at looking at how a future climate might affect our yields. A lot of groups are working on that, doing excellent work. what we had tried to do was look at it in a different way, is look at, well, how has our climate already changed? And what can we learn about how changes in variability in our climate in recent times have an impact on yields? And some work that I don't have up here because it's not finished, but what we've started to see is that we've already had enough of a shift in the warming where certain parts of the world, like in the north, like here, because of climate change that's already happened, we've had a bump or a boost in the yields of like wheat and maize and rapeseed and a few other crops. Whereas in other places in the world, we've already seen a hit from climate change. So that is looking at the mean. We've also looked at the variability in the past. And when we look at the variability of year to year of the weather and the variability of year to year in the yields, even just looking at the mean annual, mean monthly, and the extreme at the monthly level and at the annual level, we really see a decent correlation, not surprisingly, is that when it's dry, you have a shock. When it's too wet, you also have a shock. A lot of the work has been done on croplands. A lot of this kind of work has been done on croplands. There's been a lot less, and I think there should be more in the future of a focus on pastures and rangelands. We recently did a study where we I'll give a little bit of background. So the kind of overall productivity or vigor, health of a pasture is very tightly driven by the variability in the rainfall, as you all know, because it's rangeland here and it's fairly arid. What we did was look at that over time, as variability of rainfall is increasing, the overall health of pastures in those areas is going down. And when we map this out around the world, we see that a very large portion of all the rangelands around the world that we're seeing more variability in rainfall, which then it's a greater risk to our ability to raise livestock in a number of places around the world. Some other people have looked at that while there's already been a change in climate, what they've shown is that this isn't something I did, so I don't know it as well, but what they had shown is what you see in the red and the blue line is the overall kind of productivity or income, I guess, to a farmer has in general been able to keep up with changes in climate, even though the variability from year to year, which is the black line that is jumping all around, is increasing. However, what they found, though, is that while we currently have been able to keep up or offset the changes in climate, that is likely not to happen in the future. Some new areas where people are starting to work is instead of having just a focus on climate or food and climate, is really trying to pull together more of the pieces. So I'm going to show a few slides here on what's some new work that's coming out from a whole bunch of groups, but it's starting to look at the nexus of food and climate and nutrition or health. So a lot of ecologists, like me, before I started doing this work, a lot of the ecologists, when they started to work on agriculture, came at it from a point of view that it has a big impact on the carbon budget of the planet. Then after a decade or so, people saw the light and said, oh, it's actually not just a bunch of carbon, it's agriculture, and it's tons of grain. Then kind of evolved and moved forward a little bit, step by step, and started to put our work in the context of calories, the number of people that could be fed. Well, we're finally getting to a point where all the people in health and nutrition have been at for a long time, although they have not worked at the global scale. So there's starting to be more of a merging of different skills. So from a science standpoint and a social standpoint, or impact on the planet, it's a good space to work in. So some of the things we've done is we said, well, instead of just looking at where do we grow wheat or how many calories are produced, we asked, well, where is zinc produced? And not only where is it produced, but who's producing it? I'm missing a slide that's hidden underneath there, but it's fine. So as part of this exercise, what we looked at is for a nutrient like zinc, is to look at in which of the continents and subcontinents around the world where it's being produced, and then the colors there indicate whether or not it's a small farm or a very large farm. So some things that jump out is, is for zinc, that a lot of it is produced in China and mainly on very small farms. A lot of it's also in Europe, but a mixture of small, medium, and large farms. And zinc is an interesting one because some experiments that have been done in chambers where a number of researchers have grown crops in chambers where they elevate the CO2 in the chamber. What they've started to see, well, they saw this as early as the 1980s, I think, but there's more focus on it now, is that higher amounts of CO2 decrease the amount of zinc, iron, and protein in crops such as wheat, barley, oats, rye. So climate change doesn't just have an impact on yields, but it also has an impact on the quality of the food. So everything I've talked about is at the global scale. Like I said in the beginning, though, is ultimately our food is produced, individual farms, individual farmers. So the kind of main drivers that I'm talking about, how they are addressed at a local level is going to look very different if you were in a place that is irrigated or a place that's not irrigated, or have a different set of soils and topography. So the kind of strategies or challenges I'm going to move to now are not work that we've done, but I think it's important to highlight, like, I covered like a lot of bad stuff. But there are a lot of seeds of hope out there. So like in the US, with precision farming, we're starting to use a lot less nutrients, increase our yields through new technologies. Agriculture is one of the biggest drivers, or is the biggest driver of habitat loss in the tropics, as I mentioned. Oil palm is one of the drivers. And a number of companies in a very short amount of time made a set of commitments to not purchase oil palm from areas that have been recently cleared. So it hasn't all happened yet, but I think an exciting part about the role of business as a way of being a leader is that there's not a government that spans all countries or even a few countries. Whereas all the companies you see up there source their goods from all over the world. So if they are committing to a certain set of standards, that can drive change at a country level, even if there's not already a policy in place. In order to see if those of the commitments are being met and such, the World Resources Institute leads this effort to share information on forest loss and fires and harvesting areas and mills all across the world. And so this is a way of making all the information kind of open and transparent. And in many ways, I think anyway, it really accelerates implementation toward meeting a goal, because even if you have a goal that's a decade out or a few decades out, anyone who wants is able to see, like, are you on track or not of meeting a stated goal. Other things that have been happening is that with better seeds and management practices, sharing knowledge, is that yields have been able to increase. Then there are a number of programs like the One Acre Fund, which provides microloans in order to, in the early part of the season, purchase seeds and fertilizer, and they have like an extension agency-like service, and it serves a lot of people, and it increases the income on farms. From a nonprofit standpoint, or as someone who's looking at the nonprofit, it is super impressive that they measure everything that they are doing as a way of tracking, like what's working and what's not working, are they meeting their goals or not. So I think how they run their operation is very impressive for a business, even if not a nonprofit. Other pieces of like adaptation are things that like we take for granted. You know, we have a weather station. There are our forecasts on the radio, on the television. In huge parts of the world, they don't have that. So there are a number of services that are being developed either by a set of governments or a company, in this case, which is based out of either Norway or Sweden, I can't remember. But what they do for a huge number of farmers in West Africa is they take data from a certain set of stations, do atmospheric modeling, estimate the forecast for a few days out, and push that information to a farmer in the field with a text message. And it's information that they are now able to access that have never been able to access before. Other things are like are changing the type of management activities, and like how rice is planted and how it's flooded can have a huge impact not only on the yields but on the releases or production and release of methane. It's been shown if you can occasionally dry down a rice paddy, and you do it at certain times of the year in certain ways, that it can have little or no impact on the rice, but have a much more positive impact on the climate. And as the numbers show here, the adoption rate for some of these new strategies in certain places in the world is taking off at a very fast pace. So what we show here is our team and others work a lot with a set of companies and nonprofits who really want to use this information so that they can understand where are opportunities to increase yields, where are places where they are sourcing from that have more or less of an impact on water, on climate, on fertilizer use or inefficiencies. So this is a positive trend because a number of the companies and development banks that we are working with and share this kind of information are major players in agriculture around the world. To try and get our information out there to a larger audience, we've worked with National Geographic and others. So if you're interested in the kind of things I'm talking about here, but aren't interested in reading a science paper, I totally get it. And a lot of what I have been talking about here is covered in a series of articles in National Geographic, and we helped with a number of the figures on fertilizer use. The opening article as part of a series. This is that food and feed map that I mentioned earlier. Places where it's purple is mainly used for feed and fuel. And the yields work that I talked about earlier. Another way, if you're interested in finding more information about this, is we have a website or a platform called Food Matters. And what we've done there is a number of companies and nonprofits and development banks, we were finding commonly asked us a similar set of questions, like how much food is needed in the future? How do you know that? What's the impact of diet? What's the impact of waste? So rather than put together a white paper that is strong on the facts but is weak on the narrative, what we tried to do is put together journalistic-like reports that is grounded in the science, but is easier to read and has all kinds of figures and slides if you want to use them in a class or a presentation. So we have things on the expected demand, role of diet, role of waste, water, climate, nutrition, climate and pastures. We've got a whole other suite of them in the works right now. So what I tried to share here was what are some of the big drivers that are affecting food security around the world, and then what are some of the big opportunities and challenges in order to meet our demands now and in the future on a warming planet. And then hopefully the latter few slides also gave you a sense of the types of activities that are happening in various areas around the world to address a lot of these challenges. And when I had that slide that showed the seeds of success, I'd like to close with a quote here that as much as when I work on this, and at times it's emotionally hard because it's such a big challenge. But I always remember that everyone I meet at universities or nonprofits or farmers, there's a lot of people doing amazing work out there, and that certainly always it gives me a lot of hope. So hopefully that is coming through in the message as well. That's what I aim to do. So thanks everybody, appreciate it.